Thanks, everyone, for joining me. We'll try and make this quick so everyone gets some lunch. My name is Mike Nichols, and I work at a company called SoftKinetic. We are a tech-focused company that just creates depth sensing technologies. Before we jump into this, I put some of these quotes up just kind of as a reminder for us, a lot of ways that we view technologies, certainly early technology. We tend to look at it that it has its full set of features when it comes out. And that was true of the wheel, it's true of the phone, and it's certainly true of Kinect. These are early days for this type of technology, so let's just keep that in mind as we move forward. If we can move forward. There we go. All right, so yeah, SoftKinetic. We create specialized depth sensors, right? So that's just a camera with a time-of-flight sensor that sees in 3D, a lot like you or I do. We also create middleware. And the middleware is what gives us the context awareness, that real-world acquisition, which is like scanning objects or room, and also active control. So we also track the body movements of individuals. We are primarily just a technology company, so you don't see our goods packaged. We supply that technology for other people like Intel, Sony, Texas Instruments, and so on. So the question that we hear a lot always is why? Why do I want my devices to see? And what does that enable that I really want? Well, for us, I guess the simple answer is that we believe computer vision and recognition to be the single most important piece of enabling technology for the future of our computerized devices. When our technology can see and recognize the world as we do, we can really begin to develop a new way of computing. And it's technology that will enable us to be, well, it'll be more pervasive, from everything from light bulbs to our cars and certainly our PCs and tablets. It's something that the technology will be able to become more personalized. And that's really important because it's more than just recognizing who we are. It recognizes where we are and what we're doing and the environment of which we're doing it in. And this will allow us to be more predictive. You know, it can anticipate our needs. If we understand what we're seeing, if our computers and devices understand what it's seeing, then it can be more predictive and serve us better. Something as simple as turning on the lights based on our walking patterns. Or even something maybe we're more familiar with, cars that brake automatically because they're more aware of what's in front of them than maybe we are. And so there's a nice little benefit there, and also certainly more productive. And the idea being that we can open up the space to be more interactive with our devices than just utilizing the surface that's in front of us, you know, whether it's a touchscreen or using a mouse or a tablet. We can actually involve the space that's around us, so we can interact with real tools. We can interact with just using our fingers or our bodies, so we can imagine an entire new way of interacting and new types of experiences. And so there really are really three pillars of depth vision. I think mostly right now we tend to focus on kind of the active control piece. And that is actually controlling an object using either our body tracking or our hand tracking. But it's really important that it also provides that context awareness. Again, it's not just who we are, but it's where we are and what we're doing, and also the real-world acquisition, 3D scanning, providing depth information and awareness so that, you know, like the talk before, people can actually create augmented reality. Without having that depth information, you can't actually augment what you see. It's just a HUD. All right, so before we jump in, I just kind of wanted to take a quick look back, really to kind of like the origins of natural gesture and the whole idea that computers will be able to understand our movements and what that might involve. So this is from 1979. And the student at the time, Richard, began to wonder what it would be like to control a graphical user interface. So there is audio, but I'll just kind of talk over it a little bit. Should be pretty self-evident. So what Richard is doing is he's making a simple command. He's pointing at the screen. He's saying, create a yellow circle there, right? And he's pointing and telling the machine to do something. So this is a very simple task that you and I do regularly. It's really kind of a foundation for even how we develop our language. It's okay. And what Richard noticed, or noted at the time really about this thesis that he was working on, because voice can be augmented with simultaneous pointing, the free usage of pronouns becomes possible with a corresponding gain in naturalness and economy of expression. Conversely, gesture aided by voice gains precision and power to reference. That's quite a mouthful. And I think this is something that we're still struggling. This is something that's very difficult even for computers to understand today, but we're very much on the cusp of this type of reality. If I were to point at any object in the room and say, put that there, if you all followed me, you would know with relative precision exactly what I'm talking about. And that is that power to reference. I want to be able to watch that. I want to be able to move that. Those are it's a very powerful language that I think we can start to imagine what these types of devices with this technology can provide. So let's flash forward 30 years, right? The Kinect comes out, and we should all be pretty familiar with what it did. It certainly repopularized the idea of natural gesture. The idea being that you don't need to use a controller to play the games, you just use your body. But in the 4 years now since its initial release, what have we really learned? How far have we come in our understanding in incorporating our computer vision into the ability to play games and control our TV? So what did we learn? Obviously, it sold really well. 25 million units and still growing. So fantastic. It was also very polarizing. In particular, into the industry, seemed to be particularly polarizing for the press and for the developers. But it turns out really that the general public doesn't really care. They just want something that's fun to use. We also learned that latency matters. And all the worry about having the players stand up and move around and the worry about fatigue, turns out what drives fatigue more than anything is frustration. And that's frustration with controls that are not responsive or don't give feedback properly to the player. You know, people are willing to do quite a bit. I mean, they'll dance, they'll exercise, they'll do all sorts of things as long as we're giving them proper feedback and they feel like they're in control. And then I think, you know, something that most developers who ever played around with it learned pretty quickly is porting doesn't work. You really need to think about what mechanics work. You need to prototype those mechanics, and you need to base your experiences on those mechanics that work, not the mechanics that you want to work. There's plenty of things, particularly with this early generation, that we want it to do, but we really need to base our understanding and our experiences on what works. There we go. All right, some other things that maybe even more important rather than what did we notice or what didn't we see with this earlier generations. We didn't really see the killer app. I think there were some popular, there were definitely some popular titles, and there's some genres that came out that emerged to be very popular and resonate with the public, but there was not a single title that really created that broad wave through the entire industry. Multimodal play. Games didn't really leverage the wide distribution of what depth actually provides. Again, they were just focused on the main control piece. And that's too bad, because I think there's a lot more to what depth provides that we can use in our games than just direct control. There's a lot of things in direct control. I think you know, it's just the example that I put down there at the bottom is, you know, a driving wheel may not make a car game actually work, but it adds immersion. It makes it feel better, makes it feel like you're actually driving a car. The same thing can be done for regular control play. It would be great to be able to play a squad-based game, to be able to point in a direction and have my other teammates that are online understand what I'm communicating, rather than having to push a pre-animated button. Those are a lot of things that you can do that add immersion, but don't take away from the direct control of the game. And this was kind of a tough one and kind of an interesting thing. I think there really was no innovation on the console. Unfortunately, we saw really the mechanics that launched with the console are still with us today. Titles are still using, they haven't really innovated on top of that. Versus the PC community, which is exploding with innovation. None of those innovations seem to be coming back. There isn't an outlet, unfortunately, on consoles currently that allows for that type of innovation. And you know, maybe for a bunch of reasons, people are spending too much trying to hit the home runs, and there's not enough small little core pieces of experiences based around a great mechanic that people can access on the consoles. So that's something we hope, that's something we definitely hope can change. And to do that, actually, SoftKinetic is announcing this week that our DepthSense HT-lib, which is a full-body tracking library, is available for the PS4. So you can have the same features that you would have developed for any motion tracking game. You can now develop that for release on the PS4. What we're really hoping here is that we can push the innovation a lot farther than what we've seen. We really want developers to push multimodal play, to push the passive features. And we want to hear from developers directly so that we can help them exploit whatever it is that they would like to do. Innovation for us is really important. We had a really nice time working with Sony, getting this working, and we're super happy. I just want to show just some of the types of things that we play around with in the office quite a bit. Again, this is a control feature, but I mean, the first thing someone does is they grab a Move controller, because that's already a great platform, and if you combine that with full body skeleton, this really is kind of the ultimate fantasy play. It's hard not to do this and just laugh your head off. But again, it's utilizing the full body. It's using something, an additional controller, in this case, the Move. But certainly, this applies to any kind of control play. So we've got other features that we'll be announcing too as we go on later in the year. Okay. So a little bit more about what's coming down the road. Certainly, you know, right now, obviously, Kinect and the Sony are the largest platforms for vision, but there are other platforms that we're working on as well. In the PC and mobile space, there's Intel RealSense. Right? So later on in the year, hopefully, we'll be seeing the new PCs and laptops that will also be also come with an integrated depth camera. If you've seen Google Tango and Aura and the phone, these things are all depth-enabled devices. Certainly, VR is an area we're looking at. And we really feel like as we push through VR, that is something that is really an enabling feature for AR. Again, mobile. So we've got Tango. It's about putting human senses into a tablet. What does that really mean right now? It means that it can scan the environment. For Project Aura, we also want to integrate a depth camera into that and bring that even to a smaller device. It's a little bit different now. When we look at the mobile applications for depth, it's quite a bit different than what we've seen on the console side. So we're looking at a world-facing camera rather than a user-facing camera, and that brings up completely different use cases for depth camera. In this case, this is what Qualcomm just showed at SIGGRAPH recently, using our sensor to do scanning. And here he's scanning an object, and now he's additively adding in more detail as he moves around the object. And you have access to the normals, certainly just to the model itself. This is a great application in the sense that not everyone is super creative. It's nice to think that everyone would have a 3D printer in their home, but then the idea of someone actually having to create an object to 3D print is very scary for a lot of people. So it's nice to be able to give people the ability to be able to scan any sort of real-world object and gives them a place to start. Certainly in productivity side, it's also nice, I think, for developers. It also gives them an opportunity to be able to scan in objects or people or anything like that. It gives them a nice reference point. And as we are continuing to develop that, we're looking at AR, and the way we look at AR is certainly when we first tried it on, we felt, first of all, it was a wonderful experience, but we felt what was missing was us, that we had this great sense of visual presence, but not really a great sense of ourselves being present in the environment. So we're prototyping different ideas with the idea of bringing your hand tracking into the mobile, so you actually see your hands in VR and you're able to manipulate objects in VR. It's kind of a no-brainer, I think, once you try it, and certainly I welcome everyone to come down and try it in the demo downstairs afterwards. But we also found that traditional controllers are just far too complex for VR interactions. Using a keyboard and mouse, unless you're a serious pro, isn't something that people just immediately pick up and find intuitive to control. And so using your body and your hands, it's something that is very satisfying. It's a very, in a sense, it's actually a grounding experience because it's so isolated. When you actually pick your hands up and you put them in front of your face, it creates a sense of scale for the user. It grounds them in that experience immediately. And they immediately know what to do. I mean, we know how to grab objects. So if there's an object to grab, or if it's implicit in its design, you will know how to interact with it because you actually see your hand. And we also feel like multimodal input is really key. So that's an area that we're looking at pretty heavily. How do we interact not only with our hands, but how do we also interact with our hands using another object? It's a very powerful feeling to be able to, the idea there being if I had a joystick and I'm flying a spaceship, that I can reach down, I see my hand in the spaceship, and I can look down and grab the controller as my control for the ship, but I also have all the buttons in the interface around me, and I can simply just reach out and interact with that environment. I can put my shields up and see what's in front of there, or turn my throttle up. So I have this multimodal use of controls to be able to enjoy the experience with. This also brings up something that's immediately kind of powerful feeling there with VR, in that it creates an immediate social connection. When it's your movements, you can convey a lot of information just by moving around, just by pointing, just by doing gestures, even if there's no audio. So you can get a sense of the personality of the people that you're playing with. Say if it's a poker game in this sense. But there's a lot of emergent behavior that can come out of that. And that's a very, very powerful feeling. It also creates something where every action is unique, and it creates very interesting scenarios. I think, sorry, I lost track, but everything that we do or are working for in VR is helping AR then be better. We certainly don't want to walk around with AR glasses and control that experience with a tablet or a phone. It just doesn't really make any sense. I mean, why have glasses if you can't just reach out and point at something and ask what it is, or get directions and be able to see that actually being projected in an environment? There's a ton of use cases. So the great way for us to develop the technologies that are needed for AR are certainly through VR, and we're learning a lot. Latency was a big issue that we're working through. Field of view is another one that's interesting. Yeah, so we're hoping that, that as we work through this process, we're inviting a lot of developers. We're giving away all the software on our website. There's always free versions. And our hardware is always available. And check us out, please, on SoftKinetic. I'm available, actually, if there's any open questions, but I'm also available anytime afterward just to answer anything. And we do have demos downstairs, so it'd be nice to see more people come down and give it a try. Thank you. Great. Yeah.
What's the current state of the art for the resolution of our cameras?
So the question was, what is the current state of the art for the resolution of our cameras? Our depth set modules right now are QVGA. Yep. Yeah.
What's the max distance that you can reach out through the camera?
So the question was, what's the max distance that the camera can see, essentially? So that is completely dependent on the power. And we have created, and we do create cameras for varying applications that are varying for distance. Take, for instance, the Sense 3D camera that we created for Intel and Creative. That was designed just for close interaction. So it's about 1.5 meters distance, you know, from essentially 10 centimeters out to here. The focus of that is just right here. So it's a single laser. We have long distance cameras that see beyond 5 and 6 meters. Those generally we call you know, like long distance cameras or living room experience cameras, you know, so they can see the distance within a single room. So if you have more power, you can project more light and certainly and see farther distance. There's other things we can do there too. We can lower the frame rate of the camera to be able to capture more light. And we have a demo downstairs using a tablet with our next gen sensor. We've actually slowed that down to about 15 to 30 frames a second. It captures more light, so it sees more of the room data, but you're doing it from a very, very low power sensor. So it depends. Even for automotive, we do light tolerant, sunlight tolerant depth cameras, but those use quite a bit of power. Yeah. Mm-hmm.
What's the lowest latency?
Lowest latency. So that's an area we're working on pretty heavily right now, in particular because of the demands of VR, because it was isolating. And just to give you an example, we found that our latency currently from image capture to host processing, PC processing, currently was around, I think, 30 milliseconds, a little bit more. When you're using the tracking on a flat panel, that was not distracting at all. But what we found when you're isolated, you could actually feel the pinch of your hand, or the movement of your hand. And what you saw on screen was maybe just like a partial second delayed. So our new generation, we're focusing on lower latency. Right now, from image acquisition to host processing, we're about 16 milliseconds, and that's dropped. That's still with USB 2, so we're dropping incredibly. So just to give you an idea, though, right now, it is imperceptible with our new hardware in VR of what you see and what you feel. But there's still room we can move, and we'll get that as low as possible because we know that there's obviously additional overhead that will come on. But right now, latency isn't necessarily the bottleneck on our side anymore. It's now really more the rendering side and the display side. Yeah? So the question was, do we work with multiple sensors for error correction and things like that? That comes up all the time, and honestly, the only reason why we don't do it is because we don't have the time. It's always on the docket, and it always gets moved down. I know people want to strangle us. It's an obvious one. We all want it, and it will get done at some point, but again, we're a technology company, so we build technology for other companies, and when we're shipping a product for someone else, that tends to go down, even though it's one of our personal favorites.
One more question on the distance thing.
Mm-hmm.
You said you have two types, long distance and a short throw.
Yeah.
Is there a variable distance that you thought about, like doing from real close up, too far away,
depending on where you are. Yeah, exactly. And right now, we do have that mode in our current generation long distance camera, but it's a manual switch, and it's kind of like the multiple camera question. There's no reason. There's nothing preventing it from being an automatic switch or a gradual switch. It literally is turning the power down or shutting off illumination. There's no physical lens change. There really isn't anything that needs to be changed other than the light output, right? So the more light you get, the farther you can see. The problem is, though, you can't see close up because you're saturating the image with, it's like shining a huge light, right? And when I back up with a flashlight, you can see the light better. But if I shine it in your eyes, it's really annoying and it's really bright. The camera can't see. So we have to shut the light down on the camera so it can see close up.
Thanks.
Yeah. Any other questions? Please come down and demo and take a look at some of the toys and some of the neat technology that we're working on. Thanks.